Alright, normally I give you an exercise to do for work, energy, and power in terms of energy principles, but instead of an exercise, I'm going to go through each of these examples with you so that it's easier for you to get through. Let's have a look here. Alright, you've got a skateboarder, mass of 65 kilograms, skates down a slope from point X to Y while experiencing a frictional force of 150 newtons. Point X is 3 meters above ground level, and the speed of the skateboarder at point X is 1 meter per second. His speed at the bottom is 4 meters per second. They want two things. Use energy principles to calculate the work done on the skateboarder by friction. So you would find these examples on one of your note packs. So we're looking at example 16, 17, 18, and 19. I'm going to go through each of these with you so that you have a good idea of how we're working. So point X is here at the top and point Y is here at the bottom. So everything that's happening here at the top, that's going to be considered our initial, and everything here at the bottom is considered our final. The other thing that you need to notice here is that the skateboarder just slides down. There's no applied forces. So we're just going to write down all the information that we have. So we have mass equal to 65 kilograms. We've got height at 3 meters. We've got G at 9.8 meters per second squared. We've got V initial at 1 meters per second. And we've got V final at 4 meters per second. We've then got the force of friction equal to 150 newtons. We would know of that the theta value is 0 degrees. We also know, we don't know delta x. That's information that's missing here. Alright, so what we want is work done by friction. Now, I know that friction is a non-conservative force. So the formula I have to use, it's non-conservative. So the formula I'm going to use for A is WNC is equal to the change in EP plus the change in EK. So that's the formula that we're using for this formula. This work non-conservative is actually the work done by friction. And if we expand this, all we're looking at is the final potential energy minus the initial potential energy plus the final kinetic energy minus the initial kinetic energy. So technically what they want is the work done by friction, so they want WF. Now I don't have, in order to do work done by friction, I could use F is equal to delta X cos theta. I have force of friction, I have cos theta. What I don't have is the displacement. But I do have the M, the G, and the H for potential energy, and I have the M and the V's for kinetic energy. So I'm going to use that information and put it into my formula. And what I've got then is mgh final minus mgh initial plus half mv squared final minus half mv squared initial. And I'm just going to pop in all my information and see where that whole thing takes me. Alright, so my final height is 0. I know my mass is 65 times 9.8 and the height was 0 minus 65 times 9.8 times 3. All of that's in 1 plus a half times 65. V final was 4 meters per second for 4 squared. Sorry, that's minus half times 65, I'll make it a bit smaller, times 1 squared. And that's all in its brackets. Right, all I'm left with here is 0 minus 1911 plus 520 minus 32.5, and I should be getting negative 1911 plus 487.5, and that should give me work done by friction at negative 1423.50 joules. So I know here, therefore, negative work is done, and 1423.50 joules of energy was removed from the system. So I know there's no conservation of energy happening there. Right, so that is how you would get to this. Mark allocations, let's just read in green. I've got a mark here. I've got a mark here, 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 and here, and one mark there. So just make sure that you have a look. These expansions that we do here of the formula, that's for you to do substitution. Right, the next one says calculate the distance between x and y. So basically what we're looking at is that distance there. So we're looking now for displacement. All right, so when I'm looking for displacement, I must just take into account what information I have. And the only formula I have that has displacement in it is the work formula. W is equal to force delta x cos theta. All right, so I'm looking for this. I've got the work done, and my force, the only force that's acting on this whole thing is friction. So it's the only force. There's no applied forces. So I have that at 150 newtons. I know that friction is always at 180 degrees to the displacement, right? And I know that the work done by friction, I calculated that in the previous question as negative 1423.50. So I have that information now. So I can, in my whole equation now, I only have one unknown. All right, so for question B, work done by friction is equal to F delta x cos theta. This is negative 1423.50 is equal to 150 times delta x cos 180. And that gives me, let's put that into the calculator, and I'm going to get 150 delta x. And then I need to solve for delta x, and delta x is equal to 9.49 meters. Right? I can either say down the slope, or I can say, remember it's a vector quantity, I can say in the direction of motion. And that is how I would get my displacement for this type of a question. So it's pretty basic in terms of where we're going to give you substitution. It's 1, 2, and then 3, 4. 4-mark question. And that is how you answer these types of questions. You just have to notice here, though, is that there were no applied forces. So in order to work out work done non-conservatively, we only had one non-conservative force. So it is possible for that to happen. All right, example 17. A cyclist pedals up a 20-meter slope. Let's just underline some of this information. 20-meter slope. The cyclist applies a pedaling force of 250 newtons. So I know now I've got force applied. And experiences a frictional force of 80 newtons as he cycles up the slope. So I know now that I'm going to take up the slope as positive. and anything going down would be negative. The speed of the cyclist is 3 meters per second at the bottom. So I know that that is my initial. The bottom is my initial at point A, and point B is at a height of 2 meters. So I've got height above the ground, and the total mass of the cyclist is 80 kilograms. My displacement I know is 20. So let's just have a look at what information we do have. Let's have a look here. Let's work here. Alright, I've got delta x here at 20 meters. I've got force applied is equal to 250 newtons. Let's say up. I've got force of friction, which is equal to 80 newtons. So by already seeing this, right, by seeing this information, I already know I have non-conservative forces. And non-conservative forces, and now I've got two non-conservative forces. It means at some point I've got to look at W net of non-conservative forces at some point. Right, he's going up the slope, and it's initially V initial is equal to 3 meters per second. At the bottom, the height we have at 2 meters at the top, and we've got a mass here equal to 80 kilograms, and we've got a G value here of 9.8 meters per second squared. Alright, that's all of our information, and let's have a look at what they want. Alright, the first thing it says, calculate the increase in gravitational potential energy. So I know we're dealing with EP. It says calculate the net work done on the cyclist by all non-conservative forces, and that takes me directly to my force applied and force of friction. Then use energy principle to calculate the speed of the cyclist at point B, which is at the top, making that V final. So initially when I read the question, I need to write down my information, and then I need to look at what they're asking for so that it's easier for me to get through the question. Let's have a look at answering these questions. Let's start with question A. Question A says, calculate the change in gravitational potential energy. So they want the change in EP, and I know that's equal to mgh final minus mgh initial. Alright, so I've got 80 times 9.8 times 2 minus 80 times 9.8, 0. And that should give me 1,568 joules. Please feel free to pause the video so that you can do it by yourself, so that it's easier for you to show that you understand the work. All right, so pause, play, have a look at the answer, and work it out that way. All right, so now I've got the change in EP done. 1, 2, 3, 4. All right, positive work done, energy increases. The next one, B. It says they want the net work done by all non-conservative forces. All right, so two ways of doing this. I'm going to show you both methods. Method 1, you could have said work done by non-conservative forces is equal to work done by the applied force plus work done by friction. And all you would have done is F delta x cos theta plus F delta x cos theta. So I know that for my force applied, it's always going to be 0 degrees. My theta value, this is theta, and for force of friction is always going to be 180 degrees. That's how it gives me forward minus backwards, essentially. Alright, so I've got to go 250 multiplied by 20 cos 0 degrees plus 80 times 20 cos 180 degrees. And that's going to give me 5,000 plus minus 1,600, so 6, is equal to work non-conservative is equal to 3,400 joules. So that's method 1, right? Method 2, if you chose method 2, and if that's the method that you're comfortable with, you would have said F net is equal to the force applied plus the force of friction, which would have been 250 plus negative 80, and that gives you 170 newtons. You then would have said work non-conservative is equal to F net delta x cos theta, and that gives you 170 times 20 cos 0 degrees, and that would have given you 3,400 joules as well. So depending on whatever method you're comfortable with, you still end up getting the same answer. So it's up to you what method you use then. All right, then the last question. The last question here says they want us to use energy principles. Here we are on this question. Use energy principles to calculate V final. All right, so let's just look at what we have here. So essentially, in order to find V final, and I'm going to use energy principles, the minute they say energy principles, I know I've got to go work non-conservative is equal to the change in EP plus the change in EK, right? Now, of this question, in question 1, they asked me to find EP, which I did. So that's done. So I have the change in potential energy. In question 2, they asked for the net work done by all non-conservative forces, which we did. That was this little business here. So that one's also done. Now we need to find VF. The only way to find VF is to use the change in EK. So let's have a look how that kind of plays out. So question C, we say work non-conservative because that's energy principles is equal to the change in potential energy plus the change in kinetic energy. So now what I'm looking at is I've worked out work non-conservative of the system at positive 3,400 joules is equal to the change in EP, which we got over here at 1,568. And now I've got to look at plus EK. So I've got a half times the mass, which was 80, VF squared, minus a half, times 80, and the VI was 3 squared. Let's put that properly. All right, so now essentially I've got 3,400 is equal to 1,568 plus 40 VF squared, VF squared minus 360. Alright, then I need to sort out all of that information. I've got 2192 is equal to 40 V squared F. Then divide both sides by 40 and I've got V squared F is equal to 58.4. And then I need to square root both sides. And I'm left with V final is equal to 7.40 meters per second in the direction of motion. And there's my final answer. So all you have to do is make sure you sort out your information so that you have the information in a structured way. So a couple of things is question A and question B can sometimes lead to information you might lead in your last question. So in these types of situations, if you messed up here or if you messed up here and then you continue to take those mess ups, in here we'd give you part marks for some sort of continued accuracy, but you will be initially penalized for final answers because you made that error. So please just be extra cautious. All right, let's have a look at the next example. All right, exercise example 18. All right, it says a force is applied. A force is applied to a trolley to move it up a ramp length 15 meters and a vertical height of 1.2 meters as shown in the diagram below. So we'll add in the information in a bit. The mass of the loaded trolley is 90 kilograms. The frictional force between the wheels and the surface, so that's friction, is 60 newtons, and the trolley is moved up at a constant velocity. Right, once we've got that information, let's get everything down. Make sure you write down all your information, and then we can start looking at the questions. Alright, if I'm looking at this example, let's have a look at what I have. I know I have a mass here of 90 kilograms. I also have a displacement of 15 meters. And I know that that is up the slope. That's what we're looking at. I also know that I have a vertical height of 1.2 meters. And that's there. 1.2 meters. I know that I have velocity is constant. Now, if my velocity is constant, then I know some sort of other information. I know there is no change in velocity as acceleration is equal to 0 meters per second. So there's no initial, V initial, there's none, and there's no V final. Hopefully you can start seeing where we're going to get to with that. I do know that there is just put this information on the side. I know that there is a force applied, but I don't know what that force is. I do know the theta value will be 0 degrees. I also know that I've got a frictional force, and that is sitting at 60 newtons, and that theta is at 180 degrees. So that's the kind of information that I do know, and we need to work with that as we get through this. All right, the next thing it says here, let's look at the questions. A, the magnitude of the net force acting on the trolley as it moves up the ramp. All right, and give a reason for your answer. So they want F net, essentially. All right, they want you to calculate the increase in gravitational potential energy of the trolley. And increase means they want to know what was your change in gravitational potential energy. The last question, they want us to use energy principles to calculate the magnitude of the force or the applied force that's on this whole system. All right, let's just get started here. All right, question A, they want to know what's the net force. So in this setup, I could say F net is equal to forwards minus backwards. I could say F net is equal to F1 plus F2 plus F3 and so on. I could also say that F net is equal to MA. All right. Now in all of these situations, I need to notice that in this situation here, the first one, I have the backward force, which means I have friction, but I'm not sure what my forward force is. So that's not a very useful or helpful formula, so I can't use that. In my second formula, I know force of friction here, but I don't know much else, so I can't use that. But if I look at F net is MA, I know the mass, and I know the acceleration. So of the mass that was given to us, but of the acceleration, they tell us that velocity is constant. And if velocity is constant, then acceleration is equal to 0 meters per second. And if the acceleration is equal to 0 meters per second, then I can say F net is equal to MA, which is equal to mass times, what's the mass? 90 multiplied by 0, and therefore F net is equal to 0 newtons. So now when you answer a question like this, they're asking you to give a reason for your answer. So your answer is F net is equal to 0. 1 mark there. The second thing that you need to show is how did you get there. Velocity is constant, which means acceleration is 0 meters per second. And according to Newton's second law, to Newton 2, F net is equal to ma, and you can do a little sum for them and show that F net is equal to 0. But you must discuss constant velocity. You must show that you know that acceleration is equal to 0 meters per second. Right, question B. Question B says, calculate the increase in gravitational potential energy of the trolley when it reaches the top of the ramp. So all we're looking at here is we're looking at the increase in gravitational potential energy. So I know I have change in gravitational potential energy is equal to the final potential energy minus the initial potential energy. So I've got mgh final minus mgh initial. And make sure you substitute in all of these values so that you can get the marks. So I've got 90 times 9.8. And my height at the top of the ramp was 1.2 minus 90 times 9.8. And my height was 0 at the bottom of the hill. So I ended up with 1058.40. So that's the change in potential energy as my final answer. So just check here. 1 mark here, 1 there, 1 for that, 0 over there, 1 for your final answer. So double check your mark allocations. And let's have a look at our question and what they want from us. It says here, use energy principles. Question C, use energy principles to calculate force F. Right, now I know that if I'm using energy principles and I've got non-conservative forces, then I have to use the formula WNC is equal to the change in potential energy plus the change in kinetic energy. All right, so let's just analyze all of this stuff first. Right, the first thing I need to understand is what we mean by work done by non-conservative forces. I must first identify those forces. So I know that I have the work done by friction plus, the work done by force applied plus the work done by friction is equal to, now the change in potential energy we already calculated there. So I know that this is 1058.40. Done. So that's sorted out. Now my EK. The first thing I must understand about EK, in order to have EK, there must be a change in velocity. That's the only way I'm going to get kinetic energy. But in this question, the first thing I have is that velocity is constant, which means essentially there are no changes in velocity. Also, my acceleration is equal to 0 meters per second squared. So I know that under these conditions, my kinetic energy is going to be equal to 0 joules. So if the velocity is ever constant, then EK has to be 0. So in my formula, plus 0. Now you get a mark for that, so please make sure that you indicate that you understand that there's no kinetic energy in the system because my velocity is constant. All right, so I've got now F delta x cos theta plus F delta x cos theta is equal to 1058.40. My subject of my formula is F. So now I've got F 15 cos 0 plus 60 times 15 cos 180 is all equal to 1058.40. Right, the next thing then, I've got 15F minus 900 is equal to 1058.40. And now I've got 15F is equal to 1958.40. And force is equal to 130.56 newtons. You can say up the slope. You can say in the direction of motion. You can even say just upwards. And that is how you would do a question like this. So there is quite a bit of analysis involved. You need to make sure that you understand what work non-conservative is. How do you break that up? If you've done calculations in previous questions, bring that down. If you don't want to bring it down, you're more than welcome to do the whole step. For the change in kinetic energy, read your question. Understand that equations of motions, graphs of motions come in here. And if there's no change in velocity, then your EK is 0. There is no change in kinetic energy if there is no change in velocity. And that is the last question C over there for this example. Okay, example 19. It says a trolley of mass 2 kilograms moving up at 4 meters per second rolls from point A to B along a frictionless slope. The length of the runway is 3 meters and the vertical height between points A and B is 0.6 meters. Now let's just sort all of this information out. Here's point A and there's point B. Point A is at the bottom and point B is at the top. So the one thing that may confuse you is this word here, rolls. Now rolls tells me it moves without force, right? There's no forces, as in no applied forces. Now that is important because it tells me that I've lost a non-conservative force. The other thing I can see here, right, if you can notice, it says frictionless slope. Frictionless slope tells me, again, I have no friction, which is self-explanatory, but no friction tells me that with no applied force and no frictional force, it means there are no non-conservative forces. There are no non-conservative forces acting on this object. The word rolls is going to be a problem for you because you're going to wonder, how does it move without force? But remember, this is hypothetical situations. This is in science. It's not like where it's a real situation. If something had to roll uphill, we would have to apply some force, but we're not considering that for this question. We're just going to use the words rolls telling us that it's moving without a force. Essentially, if I had to put an object, this cart, on this slope, and it was rolling upwards, the only forces acting on it going down would be Fg and then Fn. Essentially, I can then also say, if I wanted to, I could have had my F perpendicular, and then going down the slope, I'll have my F parallel. All right, so those are the forces that are acting on this object. So if that's the only forces, I know that Fg and Fn are perpendicular forces. And perpendicular forces mean that your net work is equal to 0 joules because I have conservation of energy. That's what's happening so far. The fact that only perpendicular forces, that's what this rolls tells me. that I only have perpendicular forces acting on my object. Alright, let's account for all our information that we need for this question. The first thing we have here is mass at 2 kilograms. We've got a V initial at 5 meters per second. We've got vertical height at 0.6 meters. Delta X is 3 meters. I know my mu value is 0, so therefore there's no friction. And I also know that it rolls, and therefore no applied force. I also know that G is equal to 9.8 meters per second squared. That's all the information that I have right now. And then I know V final is an unknown, essentially. Alright, so what we need to do is have a look at our questions. The first question says, is the mechanical energy of the trolley conserved as it moves from A to B? Explain your answer. B says, calculate the speed of the trolley at point B. Then it says, now suppose, right, things are changing. Suppose the surface of AB is rough and the trolley experiences a constant frictional force of 4 newtons from X to Y. So now what we mean by X to Y is that we're still going from here, but X to Y is this pathway, let's put a Y here, is a pathway that has friction. So it's still A to B. Will the trolley reach point B? Justify your answer. Will it reach point B means, does it have enough energy to reach the top? Which means if your value that you're looking for, if you're, let's say we're looking for kinetic energy, which we should be looking for, if the EK is greater than 0, then we will have enough energy. If the EK is less than 0, then we will have not enough energy. You see, this is the reason I'm going through these examples with you, because it's not enough to just make you go and do it alone. You do need some sort of assistance. All right, let's start with A. A says, is the mechanical energy of the trolley conserved as it moves from point A to B? Explain your answer. All right, let's start here. A. All right, first of all, I know that on this thing, initially, it only has these forces, perpendicular forces. So if it only has perpendicular forces, then it must mean that I have conservation. So you must first answer the question, yes, the mechanical energy is conserved. And that's where you get 1 mark. The second mark says, explain your answer. Then you say, the only forces that act on the trolley or object are perpendicular forces. Right? Like Fg or Fn, which are considered conservative forces. So that word only is very important. Conservative forces which do no work on an object. So this is the kind of answer you have to write. You have to talk about the types of forces. That's the first thing. All right, so answer the question, types of forces. You must mention the word conservative forces. You must mention that no work was done. These are hefty theory type questions that we expect you to be able to answer. Right, the next one is B. B says they want the speed of the trolley at point B. Right, speed of the trolley means they are looking for V V final, right? Now in this situation, if I'm looking for V final, I know I can't use WNC. I'm not allowed to use that formula because I don't have any applied forces, I don't have frictional forces. I need to use a formula that leads to conservation of energy. Now, if I have conservation of energy, I have a formula for that. I can say that the mechanical energy at point A is equal to the mechanical energy at point B. This is the formula you have to use, which means the potential energy at point A plus the kinetic energy at point A is equal to the potential energy at point B plus the kinetic energy at point B. So that's the formula you have to use. So this formula is for conservation of mechanical energy, right? So that's what we're looking for. You can't use W conservative is equal to negative EP because we are looking for V final or V at point B. So it's not possible. That formula does not have kinetic energy, so I can't use that. All right, so I'm just going to expand my formula, and I've got mgh at point A plus half mv squared at point A is equal to mgh at point B plus half mv squared at point B. And all I need to do now is substitute in all my values. So I've got 2 times 9.8, and my height was 0 plus a half times 2, and my velocity at point A was 5 meters per second squared. My mass at the top was still 2 times 9.8, but at point B I was at a height of 0.6 plus a half times 2 V at point B squared. And that is what we're looking for, the velocity at point B. So now I've got 0 plus 25 is equal to 11.76 plus a half times 2 is just V squared B. Alright, I sort all my information out and I'm left with 13.24 is equal to VB squared, square root both sides, and V at point B is then equal to 3.64 meters per second in the direction of motion. And that is how you would get the final velocity. So this formula here is not viable because of what we're looking for, but you are allowed to use the conservation of mechanical energy if your object is only, that's important, under the influence of perpendicular forces. That's the condition for that kind of situation. So please make sure you understand how we got there. All right, for the last question for this setup, it says here, suppose the surface AB is now rough. It experiences a constant frictional force of 4 newtons as it moves from X to Y. That's the new setup that we have here, X to Y, yeah. All right, will the trolley reach point B? All right, so let's have a look at what information we do have. I know that when I have conservation or forces of conservation, or if I have conservation of energy, I know that my formula is mechanical energy at point A is equal to the mechanical energy at point B, right? I also know that what that means is that my kinetic energy plus my potential energy at point A must be equal to my potential energy plus my kinetic energy at point B. But in this question now, I've got more information. The information that I have is that I've got a force of friction equal to 4 newtons. Now, if I have force of friction, I have non-conservative forces. And when I have non-conservative forces, they're either going to add or remove. They will either add or remove energy. So what we need to do is we need to take it into consideration. Now, in previous videos, I showed you that how we take it into consideration is that because these non-conservative forces do work, I will end up with work done by non-conservative forces. Those non-conservative forces are the forces that add or remove energy. So I've got to compensate for that by adding that to my system. So now I've got mgh at point A plus half mv squared at point A plus work done by non-conservative forces is equal to mghb plus half mv squared at point B. That is a formula, this formula here. If you look at previous videos, I said to you that how we compensate for it or how we derive the formula for non-conservative forces is that we compensate for the fact that there is work being done by a frictional force. I also know of that frictional force that the theta value is equal to 180 degrees. So a change in mechanical energy, what I have now is by adding this friction in here, I have a change in mechanical energy because of that friction as I'm moving from point X to Y or A to B or whatever we're calling it. So now all I can do is enter in my information and I can say, I know mgh at A is equal to 0. I know that half mv squared at point A is equal to 25, so plus 25, plus the force of friction delta x cos theta is equal to, I know my mgh at B is 11.76, plus I'm looking for the EK at point B. Do I have enough kinetic energy? So this here is what we're looking for. Do I have enough kinetic energy here? Let me just make a note. Is there enough? I'm going to show you a few methods so that you can see what method you'd prefer. Is there enough EK at point B to show that it reached? Okay, so that's what we're looking for essentially. All right, so I've got here on this side 25 plus 4, my displacement was 3, cos 180 is equal to 11.76 plus EK at point B. Now I've got 25 minus 12 minus 11.76 is equal to the kinetic energy at point B. And that gives me EK at point B is equal to 1.24 joules. And that is a positive value. So therefore, the trolley will reach point B. The trolley will reach point B. So that is the first way you could do this. You could work with conservation of energy and then compensate for your work done by non-conservative forces. Or let's have a look at some other methods on how to. All right, the second thing you could have done here is sorted out everything separately and then taken it forward. The first thing we understood is that your mechanical energy at A, you knew that was 25 joules. And your mechanical energy at point B, that was 11.76 joules, right? You also know that you had work non-conservative, and that was just going to be work done by friction, right? I also know that if I have my mechanical energy at A and I have friction, it will reduce the mechanical energy. Friction reduces mechanical energy. So now if I started off at point A with a very high, see, this is a greater value, and as I go to the top, it gets less. Something was reducing that mechanical energy. So what we do is we add the work done by that non-conservative force is equal to EM at point B, right? Because it's reducing. So what I would have said is 25 plus F delta X cos theta is equal to my mechanical energy at point B. So what we're looking at here is we need to find if the mechanical energy at point B is enough even if I've got friction. So now I've got 25 plus 4 times 3 cos 180 is equal to the mechanical energy at point B. So I've got 25 minus 12 is equal to mechanical energy at B, and that gives me a total of 13 joules, right? Now this value here is with friction, right? But this value here is without friction. So what we then look at is we look at the difference between the EM friction versus the mechanical energy without friction. So all I'm going to say is the kinetic energy at point B is equal to the kinetic energy, to the mechanical energy when there is friction minus when there isn't friction, and 13 minus 11.76 is going to give me 1.24 joules. Right, so that is how you work out this type of question in another way. Right, the third way of sorting everything out is something that you may be more used to. Let's have a look at how that looks. Three different. Right, the third way works like this. I know that work non-conservative is equal to the change in EP plus a change in EK. I now have work done by friction is equal to, I have EP final minus EP initial plus EK final minus EK initial. Right. Of this information, let's just look at what we do have and what we don't have. Right, work done by friction I don't have. So I know that I've got to work that out. F delta X cos theta equals the change in EP, right? That's something that I might have to work out. So MGH at point B minus MGH at point A. That's something. Plus, I need to find the EK final now that I've got friction. So I've got EK final minus, because that's what I'm looking for, half mv squared initial. Alright, so my subject of my formula is over here. All right, let's sort that out. So in terms of friction, I know that it was 4 times 3 cos 180 is equal to 2 times 9.8 times 0.6 minus 0 plus EK at point B minus a half times 2 times 5 squared. Okay. On this side, I'm left with negative 12 is equal to 11.76 plus EK at point B minus 25. Sort all of my left-hand side and right-hand side out, and kinetic energy at point B is therefore 124 joules. So I could use anyway, I just needed to realize that in my question, if they're asking you if it has enough energy, the type of energy that we're looking at is kinetic energy. Kinetic energy determines the motion. If you have enough kinetic energy, you're going to reach a certain point. You're going to be able to move there. If you don't have enough kinetic energy, you're going to fall short. So we needed the EK. So therefore the EK is greater than 0. And the trolley, please make sure you answer the question, will reach the top, or you can say point B. Up to you how that's going to go, but that's basically that kinetic energy. It's up to you what you're going to use. Once you're done with this, then you need to go and have a look at the next section that we're looking at, and the next section deals with power.